Somewhere this week you'll sit in a demo and somebody will say the word agent. They'll say it about a system that follows 4 fixed steps and about a system that runs until it decides it's done. Those two things have almost nothing in common. Underneath the word there are 6 shapes. Almost every AI system anyone will sell you is one of them, or a few of them stacked. The shape isn't a technical detail. It decides how the thing fails, what it costs when it's busy, and whether anyone can tell you either number before you sign. Last episode was 6 owners, names against a system you already run. This is a different 6. This one is about telling systems apart before you buy one. Same company as always. You run support at a mid-sized software firm, a few thousand tickets a month, and an assistant that answers customer questions out of your help center. Hold on to one thing. That single job, answer a customer's question, can be built as any of the 6. Same input, same output. 6 different systems behind it, with an order of magnitude between their costs and failure modes that have nothing in common. So, cheapest and dullest first. Shape 1 is the chain. Fixed steps, same order, every single time. Think of an assembly line. Nothing gets packaged before it's built, and nothing gets inspected before it's assembled. Each station does one narrow job and hands the result forward. Built as a chain, your support assistant does 4 things in order. Read the ticket and pull out the product and the problem. Search the help center. Draft an answer from what came back. Check the draft against the source before it goes out. 4 steps written by a person in that order forever. Nothing at runtime decides anything about the sequence. That's the strength. Every step can be tested on its own, priced on its own, and swapped without touching the others. When the answer is wrong, you know which station broke. Where it quietly fails is step 2. If the search comes back with nothing useful, the chain doesn't stop. It drafts an answer anyway, because drafting is what step 3 does. A bad early result rides all the way to the customer wearing the confidence of a finished process. So the question is, what happens when a step returns nothing? If the answer is, it continues, you don't have a chain. You have a slide. Shape 2 is the router. 1 door in front, several lanes behind it. This is the front desk of a call center. You don't want billing diagnosing an outage or support rewriting a contract. Something at the front reads the request and picks the lane. Your assistant gets a password reset, a billing dispute, a how do I question, and a legal complaint through the same box. Those shouldn't all be handled by one model with one set of permissions. So a small, fast, cheap classifier reads the request and sends it somewhere. That's the whole shape, and it's the most common thing in production by a wide margin because it's what makes the economics work. Where the router quietly fails is that misclassification is silent. A chain that breaks throws an error. A router that guesses wrong produces a fluent, confident answer from the wrong department, and nothing anywhere logs a complaint. 2 questions then. What's the fallback lane when it isn't sure, and how often does that fire? A router with no fallback isn't sure less often. It just doesn't tell you. Shape 3 is the fan out. The same fixed steps as the chain, but the ones that don't depend on each other run at the same time. Planning a conference, one person books the venue while another confirms speakers, while a third handles catering. Nobody's waiting. They meet at the end. For your assistant, that's checking the help center, the past ticket history, and the account status all at once, then writing one answer from all 3. Same work as the chain, finished in a third of the time, at roughly the same cost. You pay per unit of work, not per minute. Where the fan-out quietly fails is the merge, and the merge is the part nobody designs. The help center says the refund window is 30 days. The ticket history says a manager granted 60. Both branches came back successfully. Something now has to choose. So, when 2 branches disagree, what picks? If the answer is the model works it out, your conflict policy is a paragraph of prose nobody has read since launch. Shape 4 is the critic, and it's where a line gets crossed. A second pass, whose entire job is to grade the first. Writer and editor. The writer drafts. The editor checks it against something, the facts, the style guide, the brief. The writer revises. Your assistant drafts a refund answer. The critic checks every claim against the article it came from, flags the one sentence that isn't supported, and sends it back. This works, and it's the cheapest quality improvement available in most systems. But notice what changed. Up to here, you knew exactly how much work happened per ticket. Now you don't, because the number of rounds depends on how the first draft went. Where the critic quietly fails is that a grader with no source is just a second opinion. Checking a draft against a document is verification. Checking it against its own judgment buys you two confident guesses instead of one, and they share the same blind spots because they're usually the same model in a different hat. The other failure is having no stopping rule. 3 rounds, then a person, written down before launch. Without it, a hard ticket can quietly cost 40 times an easy one. The question: what is the critic comparing against, and how many rounds is it allowed? Shape 5 is the loop. The system takes an action, looks at what came back, and decides its own next step. Checklist versus goal. Everything so far was a person's plan being executed. This is a system given an objective and some tools working out the order as it goes. Your assistant gets a ticket saying an invoice looks wrong. It looks up the account. That raises a question about the customer's plan, so it checks the plan. That still doesn't explain the number, so it pulls the last 3 invoices. Nobody wrote that order down. It depends on what each lookup returned. That's a real capability, and for open-ended work, it's the only shape that fits. Where the loop quietly fails is that nothing bounds it. No fixed number of steps means no fixed cost and no fixed latency. And errors compound rather than propagate. A wrong conclusion at step 3 becomes the input to step 4, which reasons confidently onward from it. It's also the shape that demos best. Watching a system reason through a problem is impressive. Watching a chain do 4 things in order is not. Guess which one is on the slide. The question: what's the step limit and what happens when it hits it? It stops and asks a person is a good answer. It hasn't come up, means nobody has run it on a hard day. Quick aside, because someone in your organization will raise it. Tool use. The AI calling a database, a search index, your ticketing system, is not one of the 6. It isn't a shape, it's a power chord. Any of the 6 can have one, and how AI reaches your systems is its own subject with its own episode. What matters here is the shape of the decision-making. Shape 6 is the manager. One agent that doesn't do the work, it decides who does, hands out the pieces, and assembles what comes back. The support assistant stops being a fair example here, so take a bigger one. An employee is relocating to another country. HR updates the record. Finance prices the package. Legal checks the immigration position. IT provisions access in the new region. Payroll works out the tax. Half of those depend on the others finishing first. Built as a manager, one component works out the tasks and the order, then sends each to a specialist with its own tools and its own permissions. The payroll specialist sees compensation and can't touch access. The IT specialist provisions access and never sees a salary. That separation is the honest argument for this shape, and it's a good one. Where the manager quietly fails is arithmetic. One request becomes dozens of model calls, the coordination is itself a model call, and every message between agents is tokens, for the same business outcome that's an order of magnitude or 2 more expensive. And it's the shape most likely to be recommended for a problem a router and 2 chains would have solved. The second failure is that the manager is a single point of failure with a very large job description. When it misunderstands the goal, 6 specialists execute the misunderstanding perfectly, in parallel. The question: how many model calls does one request make, and can you see them? If nobody in the room knows, nobody knows what it costs at 10 times the volume. Look at where that line sits, because it's the only thing on the frame you have to remember. Above it, chain router fan out, you wrote every step. Its only freedom is which lane, and the work per request is a number you can put in a spreadsheet before launch. Below it, critic, loop, manager. The system decides how much work to do. That's the whole difference, not intelligence. Whether the volume of work per request is yours to set or it's to discover. Everything people find surprising about running these sites below that line. The bill that tripled in a month, nobody can explain. The failure, nobody can reconstruct, because the path was different that time. That's not an argument for staying above it. Some problems need what's below. It's an argument for knowing which side you're buying. Real systems stack these. A router at the front, a chain in each lane, a critic on the 2 lanes that touch money. That's not a compromise. That's what good looks like. But there's a specific gap worth watching for. The demo shows the loop, because the loop demos beautifully. What ships is usually a chain with a router in front, because that's what survives real volume. That gap isn't necessarily dishonesty. It's usually the difference between a prototype and a product. It is entirely on you to ask which one you're being quoted for. Three questions do most of the work, whatever the shape turns out to be. How many model calls does one request make? What's the limit and what happens when it's reached? And when it goes wrong, can you show me the path it took? A vendor who can answer those built one of the six on purpose. A vendor who reaches for the word agentic instead has told you something too, just not the thing they meant to. The temptation with a list like this is to ask which shape is best. Wrong question, and the right answer is boring. Use the simplest shape that reliably solves the problem. Adding agents doesn't make a system smarter. Often it just makes it slower, costlier, and much harder to explain to whoever asks why it did that. And keep the deterministic parts deterministic. Calculations, permissions, validations, fixed business rules. Ordinary software has done those correctly and cheaply for 40 years and never once made something up. If you want one thing from this, next time somebody says agent in a meeting, ask which of the six. Not to be difficult. Until that word resolves into a shape, nobody in the room is talking about the same system. And if the shape sits below the line, the previous episode is the one you want next. The six names that have to go against a system, deciding how much work to do without asking. Next time, how any of these actually reach your systems, the plumbing, the standard everyone's adopting, and what it opens up. If this was useful, subscribe. See you next time.